Good evening, students. It is me in my basement. Welcome to my house. I'll be teaching from here for the next 2 months, and hopefully we'll be all right. So this week, our goal is going to be to do one section and one section only. It is chapter 5.1 about using fundamental identities. You'll notice here that I have a notes like I usually do in class. You are welcome to print them out, not from the video, but there is a file attached in Google Classroom where you can print out the notes if you would like. Of course, you don't have to. You can just take the notes on your own paper. But I would encourage you to take the notes, and I will show you why. For each of the examples, I actually am going to do one myself, and then I'm going to have you pause the video and then have you try it. So watching me do it is good, but then you doing it and having me check your work is better. So we'll do that. The topic is about the fundamental identities of trigonometry. There are 23 of them. See, right there. And you pretty much should have these memorized at some point. If you haven't memorized them yet, you should do it. These are the same ones that we talked about in chapter 4. So we've proven them all already. We've talked about all these guys, the cofunction identities, the Pythagorean identities. So it's really nothing new there. But we're going to use them to do proofs and solve equations. These identities can also be found right here in the Miss New Jersey's pink sheet. They are in these 5 boxes. So you also have them there. All right, without any further ado, here are your targets today. You need to be able to recognize and write the fundamental identities, and then you need to be able to use them to evaluate, simplify, and rewrite trigonometric expressions. So what I'm going to do is I'm going to go through a lot of examples with you, and I would encourage you to write this along with me. So go away that, and here we go. Good. Okay, example number 1. Now, first of all, you will notice that now I've added a little feature. This says numbers 1 through 18. So after doing this example, you should be able to do questions numbers 1 through 18 in your assignment. And I will have these numbers written on all the examples that we're going to be doing together. So that way you'll know what goes with what. So here we go. The first question is, find the value of the 6 trigonometric functions given that the secant is negative 2/3 and the tangent is greater than 0. So we did this in the past by creating a little coordinate plane. And you might recall that all students take calculus. I don't know what that is. And in this particular case, it tells us the secant is negative 3/2. If you know that the secant is negative 3/2, you know, obviously, quite automatically, that the cosine is going to be negative 2/3. So it told us to find 6 of them. We've already found 2. Let's see, where is this angle? Remember that x is an angle. So the cosine of x is negative 2/3. We could draw this picture, but I'm not going to this time. I'm going to use the trigonometric identity to answer the question. So let's see. I know the tangent is greater than 0. So the tangent is greater than 0 either in the 3rd quadrant or in the 1st quadrant. So I know that my angle x is either here or here. But it tells you that the cosine is negative. The cosine cannot be negative in the 1st quadrant. So my angle has to be in the 3rd quadrant. So knowing that, here's what we're going to do. It's going to be a little bit tricky. But instead of drawing the picture, we are going to use a Pythagorean identity. Check it out. We know that the sine squared of x plus the cosine squared of x equals 1, right? So if you happen to know that the cosine is negative 2/3, you can actually put that into this equation. And you can solve for sine without having to draw a picture. So let's see. Let's square that. That gives you 4/9. Subtracting 4/9 from both sides, I will get that the sine squared of x equals 5/9. Taking the square root, I now get that the sine is plus or minus root 5/3. However, it's not going to be plus or minus because I know my angle is in the 3rd quadrant, and the sine in the 3rd quadrant is going to be negative. And therefore, it's going to be negative 5/3. If the sine is negative 5/3, then obviously the cosecant is going to be negative 3/5. Oops, negative 3/5. Multiplying root 5/5, I'm going to get negative root 5/5. So now what I have is I have 4/6 of my answer. So there's the sine of x and the cosecant of x. Here is the secant and the cosine. So I'm missing two of them. I'm missing the tangent and the cotangent. So to find the tangent, I will use another one of the identities. I'm going to use a quotient identity. It says that the tangent is the sine over the cosine. The sine, of course, is negative √5/3. And I'm going to divide it by the cosine, which means to multiply it times the reciprocal. So I'm going to multiply it by that. And I'll get that the tangent is √5/2. Which means that the cotangent is going to be 2/√5. Or rationalized, it's going to be 2√5/5. So there we go. It had wanted us to find the 6 trigonometric ratios. Sorry about that mess. I'm still getting used to this. And we have found all 6 of them right there. So what I would like to do right now is for you to pause the video. And I would like for you to try it yourself. And you're going to try it with this question right over here. Pause. You do it. All right, we're back. So if you need to find the 6 trigonometric ratios for this one, the first ones we know. So, whoops. We know that, whoa, hang on a second. We know that I can't find how to use this pen. So I want the pen. I'm having issues. Pen. All right, that's good. So we know that the tangent of x is 1/3. And we know that the cotangent of x is therefore 3/1. So we know those two, and that's part of it. So let's see. What trigonometric identity can we use with the tangent? I'm glad you asked. We could use another Pythagorean identity. And this time we can write it this way. We can write 1 plus the tangent squared of x equals the secant squared of x. Now we know that the tangent is 1/3. And therefore this will allow us to find the secant without really drawing the whole triangle and stuff like that. So squaring that gives you 1/9. 1 plus a 9th. That'll give me 10/9. And taking the square roots, this will give me √10/3 equals the secant of x. Now, the only question is this plus or minus? So I'm going to go up here, and all students take calculus. I know that the tangent's positive. So once again, it's either here or here. And I know the cosine is negative because it's less than 0. So where's the cosine going to be negative? Well, it can't be there. So once again, this angle is going to be in the 3rd quadrant. If it's in the 3rd quadrant, that means that the secant and the cosine need to be negative, which makes this not positive, but negative, because the secant and the cosine, of course, are going to have the same sign. So this will be the reciprocal of that. So it's going to be negative. Let's see, I got to put the 3 on top. I got to put the √10 on the bottom. But multiplying by √10/√10, I should get that for the cosine. So I have the tangent, I have the secant and the cosine. I just need the sine. So for the sine, let's see, I can say once again that the tangent of x equals the sine of x over the cosine of x. And this is kind of cool because the tangent's 1/3. Which tells you that the cosine has to be 3 times bigger than the sine. And I happen to know that the cosine is this, and that is 3 times bigger than the sine, which means that the sine must be simply negative √10/10. So the sine of x is negative √10/10, and the cosecant of x will be negative, flip it upside down, multiply, negative √10. So you should have had those 6 answers if you did it correctly. Sorry I rushed, but each video has to be 10 minutes, and I'm at 9 minutes and 53 seconds. See you at the next video.